Okay, think about this for a second. Over half, like 55% of school-aged kids around the world don't have the math skills they need.
Yeah.
Not just for school, but, for everyday life.
Right.
And what's really striking is how early these gaps can show up. And they
Mm.
stick
They
around.
really persist, yeah.
So you're listening because you want to get up to speed quickly on important stuff, right?
Uh-huh.
And that's exactly why today we're doing a deep dive into something pretty critical.
Right.
How do we actually measure math skills in really young kids, like ages 0 to 8?
Huge question.
We've got this systematic review. It was published in the Educational Psychology Review just last year, September 2024.
Yeah.
And it really digs into the quality of the different assessments and screeners they use.
Exactly. In this review, it really kind of looks under the hood at these tools. It focuses on what we call their psychometric properties,
Okay.
which basically just tells us how good they are. Are they reliable? Do they give consistent results?
Right.
And are they valid? Like,
Yeah.
are they actually measuring the math skills we care about? So this review gives us a really valuable snapshot of the current state of play.
So for everyone listening, our mission today is pretty clear. We want to understand what tools are actually being used for these young kids.
Yeah.
How reliable, how valid did this review find them to be? We'll also touch on the challenges, the problems in this area and where things could improve.
Definitely.
And sort of ultimately, what does this all mean for how we understand and, support kids' math development right from the very beginning?
Okay, so to get a handle on this, first we'll need to clarify the difference between, say, mathematical assessments they track, development over time, and screeners.
Right, screeners are different.
Yeah, they're designed more to quickly flag kids who might be at risk for mathematical learning difficulties, or MLD.
MLD, got it.
Then we'll talk about what mathematical development actually covers for this age group. It's more than just counting.
Oh, yeah.
Number sense, early arithmetic, but also broader things like patterns, measurement.
Okay.
We'll touch briefly on MLD itself and how different ideas about its causes shape the tools. Then we'll look at the typical features of these tools.
And then the big one.
Then the core part, how well do they actually measure what they say they do, those psychometric properties, reliability, validity.
Okay.
We'll also talk about why finding a perfect gold standard is tricky, and maybe point out a few tools the review flagged as, well, more promising.
And you hinted earlier, it sounds like maybe not that many tools actually meet, really acceptable quality standards.
That's one of the key findings, yeah.
Yeah.
Only a limited number really passed muster across the board.
Which has pretty big implications, right? Especially for finding kids who need help early.
Absolutely.
Okay, so let's start there. Let's get a clearer picture of these different types of tools, assessments versus screeners.
Right. So the review really draws this key distinction. Mathematical assessments, think of those as the more in-depth tools.
Okay.
They're often used to track a child's growth over time, maybe before and after some kind of teaching program, for instance.
Makes sense.
Screeners, though, are designed to be quicker, more efficient.
Right, like a first pass.
Exactly. Their main job is to flag children who might be at higher risk for MLD, kids who maybe need a closer look or some extra support.
Okay.
Now, some screeners can be used to track progress, too, but the review mostly focused on how well they identify that initial risk.
Got it. So when we talk about mathematical development in these early years, birth to 8, what are we actually talking about? It's not just 1, 2, 3, is it?
No, absolutely not. The review outlines several key areas. First, you've got number skills.
Like counting.
Yeah, knowing the counting sequence, understanding that the last number you count tells you how many there are. That's cardinality.
Right.
Knowing number order, like first, second, third ordinality.
Yeah.
And being able to compare amounts, like which group has more.
Okay. Basic number stuff. Then what?
Then you move into arithmetic skills, the very beginnings of adding and subtracting. Maybe simple word problems, too.
Okay.
But it's broader than just numbers. Things like recognizing patterns.
Patterns. Interesting.
Yeah, and understanding basic measurement, comparing lengths, sizes, that kind of thing. And even early geometry, like knowing basic shapes. All that falls under early mathematical development.
And it's interesting, isn't it, that even researchers don't always agree on which bits are the most important early on?
That's a really good point. Some models really zero in on those core number skills.
As the foundation.
Yeah, as the key building blocks for later math, and maybe the best early signs of potential trouble, like MLD. Others take a wider view, saying things like spatial reasoning or patterning are just as vital.
And these different ideas probably lead to different kinds of tests, right?
Precisely. These theoretical viewpoints directly influence the tools people create and what skills they choose to focus on.
Okay. Now, you mentioned MLD, mathematical learning difficulties. Can you unpack that a bit?
Sure. MLD is basically a term for persistent problems with learning and using math, facts, and procedures. It's kind of an umbrella term.
So dyscalculia would fit under there.
Yes, it includes what some people call dyscalculia. The review notes that the exact definition can actually vary a bit, depending on the country or the researchers.
And there are different theories about what causes MLD too, aren't there?
Yes, that's right. Some theories focus on a potential core problem with understanding quantity itself, sort of an intuitive number sense issue.
Like comparing dots without counting.
Exactly, that kind of magnitude processing. Other theories put more emphasis on difficulties with processing the symbols, the written numbers, the digits.
So like seeing a 5 and knowing what it means.
Right, and how those symbol processing issues might be a stronger predictor for some kids. It's even possible MLD can come from different underlying issues in different children.
Wow. Okay.
And this variety in understanding the roots of MLD, well, it naturally leads to a whole range of different tools trying to measure these potential areas of difficulty.
Okay, so we've got this landscape. Assessments, screeners, a whole bunch of early math skills, different ways of thinking about MLD. That sets the stage nicely. So what did the review find these tools typically look like?
Well, the review found some common threads. Most are child direct, meaning someone sits down one-on-one with the child to administer it.
Okay, not something parents fill out, usually.
Generally not for these. And usually it requires a trained assessor, someone who knows how to give the test properly.
Right.
And maybe surprisingly, given how much tech is in schools now,
Yeah.
most are still paper-based. Paper and pencil formats are still dominant.
Huh. Interesting in today's world. Okay, and what about the actual math content? What skills do they focus on most?
There was a very clear emphasis identified in the review. The vast majority focused primarily on number and arithmetic skills.
So counting, adding, that kind of stuff?
Exactly. Counting, number relationships, basic calculations. What was much less common were tools really digging into shape, space, and measurement concepts.
Geometry and spatial skills seem a bit left out then.
Somewhat underrepresented in the current batch of tools, yeah.
That feels like a potential blind spot, doesn't it? Spatial reasoning is so important, not just for later math, but for, like, navigating the world.
It really is, from packing a bag to reading a map.
Yeah. So where were these tools mostly made and tested? Was there much variety there?
That's a really crucial point the review raised. There's a pretty significant geographical and linguistic bias.
Oh, how so?
Over half of the tools they looked at were developed in what researchers sometimes call weird societies.
Weird.
Yeah, it stands for Western, educated, industrialized, rich, and democratic countries.
Ah, okay.
And a huge chunk of those were originally created in English.
So mostly English-speaking Western countries.
Largely, yes. And what's concerning is that relatively few have been properly checked to see if they work well, if they're valid in different countries or with different languages.
So our understanding might be a bit skewed by where the tests came from.
It suggests that, yeah, our picture of how these skills develop or how difficulties show up might be limited by the cultural and language contexts where most tools were born and raised, so to speak.
That really highlights how important it is to think about diversity when measuring something like early math. Okay, so we know what they typically look like, what they focus on, but the main event, how good are they? Let's get into those psychometric properties. Where did the review start?
Right. So they looked at several key indicators. First up was content validity.
Which means?
Basically, does the tool actually cover the right stuff? Based on what we know about early math, does it ask the right kinds of questions, include the right tasks?
Okay. And how did they fare there?
The news was actually pretty encouraging here. For the tools that did report on content validity, often they get experts to weigh in on the items the review generally found it was acceptable.
Okay, so step one, the content seems relevant, according to experts. That's good. What's next?
Next, they looked at structural validity. This is about whether the tool's internal structure matches the theory behind it.
Okay, explain that a bit more.
Well, say a test is designed to measure two distinct things, like number sense and early calculation skills. Structural validity asks, does the data from kids taking the test actually show that these are separate things? Does the structure hold up?
I see. And did it?
Here, the findings were more mixed. About a third of the assessments and maybe half the screeners reported on this. They used statistical methods to check.
Huh.
Only about a third of those actually met the statistical criteria for a good fit.
Hmm. So some tools might be blurring the lines between different skills more than they intend to?
That's what it suggests, yeah. They might not be teasing apart those different abilities as cleanly as they were designed to.
That seems less than ideal. Okay, what about internal consistency? That's about whether the questions hang together, right? Measuring the same basic thing.
Exactly. Internal consistency tells us if the items within a test or a section of a test are all pulling in the same direction, measuring the same underlying concept.
And the results there.
Better news here. Over half the tools reported on this, and most of those reached acceptable levels of internal consistency. So generally, the items within a given test seem related.
Okay, that sounds positive.
But there's a caveat. Very few tools provided this consistency info separately for the different skills within the test. So the overall test might be consistent.
But maybe the section just on, say, comparing numbers isn't as consistent on its own?
We often don't know based on the reporting. So while the overall picture is okay, the detail for specific sub-skills is often missing.
Okay, so a mixed bag so far. Good content validity mostly. Decent overall internal consistency. But some wobbles on structural validity and the specifics of consistency. What about reliability consistency over time or between testers?
Right. Reliability is crucial. You've got retest reliability. Does a child get a similar score if they take the test again soon after?
Yeah.
And iterator reliability. Do two different testers score the same child similarly?
Okay. How did the tools stack up?
This is where things get a bit concerning again. Less than half of the assessments or the screeners reported retest reliability.
Less than half. Wow.
Yeah. And of those that did report it, only about half met acceptable standards.
So maybe only a quarter of all tools showed good evidence of being stable over time.
Roughly, based on this review, yeah. Iterator reliability was reported even less often.
Oh, dear.
Though when it was reported, it usually looked acceptable. But the lack of reporting is a big gap.
It really is. If scores jump around a lot or depend heavily on who gives the test, how much can you really trust the result?
Exactly. It makes it very hard to make confident decisions based on that score.
Okay, so reliability is a major area needing improvement. Now, let's circle back to validity, but looking at how these tools relate to other things. Criterion validity, you called it.
Yes, criterion validity. How well does a tool stack up against other benchmarks or predict future outcomes? The review looked at a few types.
Okay, lay them out for us.
There's concurrent validity. How well does this test align with other similar tests given around the same time?
Right.
Divergent validity. How well does the test distinguish itself from tests of different skills, like language?
Making sure it's measuring math, not something else.
Precisely. Then, predictive validity. How well does this early test forecast a child's math skills later on?
That seems super important.
Critical, yeah. And finally, diagnostic accuracy. How good is a screener at correctly sorting kids into at risk for MLD versus typically developing?
Okay, let's tackle those. Concurrent validity first. How well did they match up with other similar math tests?
Well, only about a quarter to a third of the tools hit acceptable levels here.
Really? Only a quarter to a third?
Yeah, when compared to established measures like, say, the Woodcock-Johnson math tests or the TEMA 3.
So even different tests aiming at similar skills don't always agree strongly.
It seems not, which does raise questions about what exactly each tool is capturing or how well.
That is surprising. Okay, what about divergent validity, making sure it's not measuring reading or language skills, for example?
The evidence was even weaker there.
Oh.
Even fewer tools showed good evidence that they were distinct from measures of different abilities, like language.
So some math tests might be accidentally measuring language skills too much.
It's a potential concern. You want the score to reflect math ability primarily.
Right.
If it's too tangled up with language, it muddies the water, especially for kids who might struggle with language but be fine at math, or vice versa.
Absolutely. Okay, now predictive validity. This feels like a really crucial one for early intervention. How well did these tools predict future math performance?
This was frankly alarming.
Oh.
The review found only one single assessment and one single screener that met acceptable standards for predicting later math skills.
Wait, just one of each out of all the tools reviewed?
Just one of each showed solid evidence for prediction.
Wow. That's a really big deal, isn't it?
It's a huge finding. I mean, if these tools can't reliably tell us which kids are likely to struggle down the road.
Then how can we effectively target help early on?
Exactly. It makes early identification and prevention much, much harder. It's a critical gap.
It really, really is. Okay, and the last one was diagnostic accuracy for the screeners. How good were they at spotting kids potentially at risk for MLD?
Here again, the numbers were low. Only 4 screeners demonstrated acceptable diagnostic accuracy.
4 out of how many screeners looked at?
The review looked at dozens of tools overall, including a good number of screeners. So 4 is not many.
Right.
And the review stressed the importance of sensitivity here, correctly identifying the kids who are at risk so you don't miss them.
You don't want false negatives.
Exactly. Specificity, correctly identifying those not at risk, is also important, but sensitivity is often key in screening. The fact that so few met acceptable standards is a real challenge for early identification.
So, across the board, it sounds like the psychometric evidence, especially for prediction and diagnosis, is pretty patchy for a lot of these tools.
Patchy is a good word for it. Significant limitations in many cases.
And you mentioned the review also talked about the challenge of having a gold standard to compare against.
Yes, that's another layer to the problem. The review pointed out that researchers evaluating these tools often don't consistently use the same high-quality, well-established measures as benchmarks.
So everyone's using a different measuring stick.
Sometimes, yeah. Or maybe not always the best measuring stick. And even when they do use established tools, there's the issue of whether the new tool and the gold standard are actually measuring the exact same aspects of early math.
Because early math is complex and maybe the definitions aren't always consistent.
Precisely. The terminology isn't always uniform. The specific skills included can vary. It makes direct comparison difficult, like comparing apples and, well, slightly different apples.
Gotcha. But it wasn't all bad news, right? Did the review find any tools that looked relatively solid?
Yes, thankfully. It wasn't entirely bleak. The review did identify 9 assessments and 6 screeners that showed the most promising evidence overall.
Okay, 9 and 6.
Yeah, these were tools that met acceptable thresholds in more of the psychometric areas they looked at, like maybe good reliability and decent concurrent validity, for example.
So some tools are definitely better than others, even if there's room for improvement everywhere.
That's a fair summary. There are some tools out there that offer a more solid foundation based on the current evidence.
Okay, so pulling all this together, what are the main things you want our listener to take away from this deep dive? And where does the research need to go next? It sounds like there's work to do.
Definitely work to do. The main takeaway, I think, is that while we have lots of tools aiming to measure early math, the quality of the evidence behind them varies a lot.
Right.
And this isn't just academic. This variation directly impacts how well we understand kids' development globally and how effectively we can spot and help those who are struggling.
And that geographical and language bias you mentioned earlier plays into this too.
Absolutely. It means we need to be cautious about applying findings from, say, an English tool developed in the U.S. to kids in a completely different cultural or linguistic setting without checking if it works there.
So what should researchers focus on to fix this? What are the recommendations?
The review laid out several key directions. First, and maybe most importantly, we need way more rigorous evaluation of the tools we already have and any new ones.
Really nail down the reliability and validity.
Exactly. The goal should be to build up a stronger set of gold standard measures that everyone can trust more.
Okay, makes sense.
Second, there's a huge need for more inclusive tools. Tools designed from the start to be adaptable and valid across different languages, cultures, countries.
Tools that work for more kids.
Right. And the review even floated the idea of more open access tools, making good assessments more widely available, not stuck behind paywalls.
That seems really important, especially thinking back to that global statistic about missing math skills. Access matters.
It really does. Third recommendation: explore and properly evaluate new ways of assessing, especially using technology.
Like tablets.
Yeah, things like the self-administered EGMA on tablets. They have potential for wider reach and maybe easier administration.
But they need to be tested just as rigorously.
You got it. We need to make sure these tech-based tools are just as reliable and valid, if not more so than the paper ones.
Okay. Rigorous evaluation, inclusivity, technology, anything else?
One final, more fundamental point. The field needs to keep working towards a clearer, more commonly accepted definition of what early mathematics actually includes.
A shared understanding of the target.
Yeah. If everyone's on the same page about the key skills and concepts, it helps ensure the measurement tools are aligned, use consistent terms, and are actually measuring comparable things.
Better evaluation, more inclusive and accessible tools, smart use of tech, and clearer definitions. That feels like a solid roadmap. So boil it down for us, the single core message.
The core message for you listening is, We have many tools for early math assessment, but their quality and the evidence backing them up are really inconsistent. And that inconsistency matters for understanding development and providing support.
Yeah, and it really connects back to that worrying stat we started with, doesn't it?
Mm.
55% struggling. Makes you wonder how much our measurement challenges contribute to that.
It's certainly part of the complex picture.
So for you listening, we really hope this deep dive gave you a critical look at the science behind measuring these crucial early skills, whether you're a parent, an educator, or just curious about learning.
Mhm.
This knowledge hopefully helps you think more critically about tests, about assessments, and why this research is so vital.
And maybe it leaves you with a thought to chew on, given that so many current tools struggle to predict future outcomes.
Yeah.
How can we get better at identifying and supporting kids on their math journey right from the start to really build that strong foundation they need?
Hmm. That's a really important question. How do we improve that early identification and support? Definitely something to think about long after this deep dive ends.